Hello, class. So today we are actually going to be covering something called a geometric sequence. Geometric sequence. A geometric sequence is relatively easy to understand. I mean, basically, what happens with a geometric sequence is you have a beginning term, and then after that beginning term, every subsequent term is multiplied by something called a common rate. Extremely easy explanation would be, well, what if I just start with 1 and then go 2, 4, 8, 16, 32, etc. Right? So this is pretty simple. We start with our first term, and then notice every single time after that, what happens is that we just multiply by 2. So this is kind of a very simple geometric sequence. You can also do geometric sequences that have fractions in them. So for example, what if I did 9, 3, 1, 1/3, 1/9, 1/27. In this case, my common rate here, so we'll call it a common rate, which is R, is in fact 1/3, right? 9 times 1/3 is 3, 3 times 1/3 is 1, 1 times 1/3 is 1/3, 1/3 times 1/3 is 1/9, 1/9 times 1/3 is 1/27. And so these are geometric sequence. So they can either grow or they can actually get smaller. And notice when they grow, they continue to grow faster and faster and faster, or when they get smaller very quickly, and then they sort of slow down. So anyway, these are two different kind of types of geometric sequences. All right, so I'm going to just go over kind of a variety of questions that could be asked about geometric sequences and just sort of how to manipulate what a geometric sequence is. For example, if one of the things, first off, we should talk about is notation. So already you can see I've written my rate as R equals 1/3. We also write things as a sub 1, that's your first term. So in this sequence, your first term is 9, while your second term is 3, and your third term is 1. And you could just continue going with that, right? So third term, fourth term. So in fact, your sixth term, or a sub 6, is 1/27. So that the subscript is just the position of the term. Then we use the term a sub n to stand for just the nth term. So what if I'm just kind of talking about a generic term in the sequence? I don't know where the placement is. I can write the nth term because I don't know exactly where it is. Great. So this would be the nth term in the sequence. There we go. All right, so let's continue on though. So if I give you, let's say I say, here's my sequence, 3, 12, 48, ... I want to know, first off, important things are, for example, the first term. Well, the first term here is super easy to figure out. It's 3. What about the rate? Well, the rate is a little trickier, although in this case it's pretty simple. Just note, okay, so every time that we go forward, what do we multiply by? Well, 3 times what is 12, and then 12 times that same number has to be 48, and that number is 4. By the way, you can also figure out your rate by taking any term and dividing by the term before it. So take 12, divide by 3. Or you can take 48 and divide by 12. Notice in both cases, these both reduce down to 4. So this is how you can find your rate. So let's do another one. So let's say, I have 7/8, 7/12, 7/18, and 7/27. Okay, so here's our sequence. And I want to know, first off, what is my first term? Well, my first term here is simply 7/8. That's pretty simple. Well, what about my r? What is my r? What is my rate? What is my common rate? Well, my common rate is going to be any term which we get to choose and then divide by the term before it. So in this case, I'm going to choose 7/12, and I'm going to divide by 7/8, which we shouldn't do that. We should multiply by its reciprocal. Then we notice, oh, 8 and the 7's cancel. The 8 and 12, those are both divisible by 4. And so since they're both divisible by 4, we cancel out the 8. We cancel out the 8, make it a 2. Cancel out the 12, make it a 3. And so my answer is in fact 2/3. Right? Great. All right. So that's how you can kind of analyze, when given a sequence, how to analyze it and come up with your first term and your rate, right? So if you want to know your first term and your rate when you're given a sequence. What if you were given your first term and your rate and you were asked for the sequence? Well, that one's fairly simple as well. For example, the first term is 3, the rate is 2. What does that look like? Well, that looks like 3, 6, 12, 24, 48, ... right? So it's pretty easy to write out the sequence. You just start with your first term and multiply by the rate every time. What if it's a little harder and I give you 98 as my first term and I give you the rate as 1/7? Well, we start off with 98, then we take 98 and we multiply by 1/7 to get the next term. If I were to do that, you would notice that this 98 divided by 7 is 14. Then I do the same thing here. I'm going to times by 1/7 to get my next term, right? Well, if I multiply 14 times 1/7, I would get 2. Then I would get 2/7 or 2/49. So that's basically how you do it. You just multiply by the rate. Even if it's a fraction, it's still not that bad. Excellent. What if, let's do something a little bit more interesting. What if I give you, okay, what if I give you the fact that, here, what if I give you the fact that my a sub 5, fifth term here, is we're going to do 27, 27/56, okay? And I'm going to give you a rate of 2/3, okay? So that's my fifth term. Well, if I ask for my sixth term, what is my sixth term here? Well, I notice that this is my fifth term. So to get from my fifth term to my sixth term, all I have to do is multiply by my rate. In other words, what I'm saying here is that any term is always the term before it times the rate. If I want the sixth term, or 5 plus 1, then I would take the fifth term, a sub 5, times the rate. So this rate here, so this is basically the formula in a sense to go from any term to the next one. So if I want the sixth term, I would just take this fifth term and multiply by 2/3. So I'm going to get 27/56 times 2/3, which is great because 27 and 3 cancel and get a 9. 2 and 56 cancel, and we get 28 there. Yeah, so 9/28. Again, if I wanted the seventh term, I would do the exact same thing. So let's say the seventh term, I would take 9/28 now and multiply by 2/3. This gets me 3/14, which is 3 over, there we go. Or what if I want to go the other way? What if I want the fourth term? It's kind of an interesting question. What about the fourth term here? Well, if I want the fourth term given this, I need to go backwards. So if I want to go backwards, instead of multiplying by 2/3, what you're actually going to do is you're going to divide by it. So in other words, what we can say is, if I want the fourth term, in a sense, what's actually happening is you're saying, all right, the fifth term is going to be the fourth term times r, right? So if I want the fourth term is going to be the fifth term divided by r. Pretty simple idea. So I'm going to take my fifth term, and I'm going to actually divide it by r. In other words, I'm going to take 27 over 56, and I'm going to multiply it by 3/2, which nothing cancels here, which is kind of ugly, but that's okay. 81 over, this is going to be 112. And there you go. So that would be your fourth term. Okay. Excellent. All right. Now, I then want to move on and do something, make this a little bit easier. Because at the moment, the only way we can get to the fourth term is to choose something and then either multiply or divide by r a number of times until we make it there, you know. But there's actually a better way to do that. We have something called the explicit formula for what is the explicit formula for a geometric sequence? Well, the explicit formula for a geometric sequence is you can find any term by simply taking the term before it, or the very first term, and multiplying by the rate times n minus 1. So let's say, for example, let's say I give you this one. Let's say I give you the 5, we'll do 15, and then 45, ... What if I give you that? And then I ask, well, I want to actually know, what is the 10th term down the road here? Well, first off, note that my first term is 5, and my rate here is 3. How would I figure out the 10th term down the road? Well, I would say, using my explicit formula, the 10th term down the road here is going to be my first term, which is 5, times my rate, which is 3, to the power of n minus 1. Well, n minus 1, on the other hand, here's n minus 1. The n is, since I'm looking for the 10th term, the n is in fact 10. So I'm going to do 10 minus 1 here. This is going to be 5 times 3 to the 9th. Now, these things grow really quickly. So what is 5 times 3 to the 9th? Well, 5 times 3 to the 9th is 5 times 3 to the power of 9. Hopefully you can see that. And that is going to actually equal 98,415. In other words, this is about, by the way, this is about 9.8 times 10 to the 4th. Because geometric sequences grow so quickly that by the time you get to in this case, by the time you get to just simply the 10th term, you're already in the 10,000s. So it grows extremely quickly. So I'm going to take a step away here since we're at 15 minutes on this video, and I'm going to load another one kind of working with the explicit formula, but this is a good introduction. Anyway, so I'll post the homework, and we'll probably go over some of the kind of trickier problems over a Zoom meeting or whatnot. Anyway, hope you're all doing well, and take care. Thanks.